Hello fans, welcome to our channel Edisam Educators. So in this video, we'll be looking at solving exercises that relates to logarithmic equations. This is the part 2 of exercising, solving exercises relating to logarithmic equation. And this is our 8th lessons on our series on logarithmic. So in case you've missed the previous lesson, make sure you go over them. And before we proceed, please, if you're not subscribed to this channel, make sure you subscribe and also click on the bell icon so that you will always be notified whenever we upload a new video. And go ahead and like the video. So without wasting your time, we are moving on to the lesson right away. So this is a continuation of the exercises on logarithm. So we started in the previous lesson. We solved some logarithm exercises. So we are continuing from where we stopped. So the first exercise we're going to solve is we're going to simplify half log 8 base 4 plus log 32 base 4 minus log 2 base 4. So what do we do right here? How do we go about this? What we do is we're going to we are going to solve this as a. So the first thing we'll take each part. We're going to take each part, although they are all log 4, log 4, log 4, log 4. There are many ways of solving it. There are many ways. We can actually use the fact that we can multiply these two together and divide by this one, because this is addition, this is subtraction. And we can take them individually and solve. So I'm going to take them individually. So for log 8 base 4, log 8 base 4. This is same thing as I can actually apply change of base here. So 4 is related to index 2. 8 is related to, 4 is related to base 2. 8 is also related to base 2 as well. 4 is 2 raised to the power 2. That is 2 times 2. 8 is 2 raised to the power 3. That is 2 times 2 times 2. So we're going to replace 8 and 4 with those numbers. So that means that we can actually introduce change of base. And the change of base is going to be a common base, which is base 2. Base 2. This is the base, base 2. This is the base 2. So we're going to apply change of base here. So this is going to be log 2 base 8 divided by log 4 base 2. Log 8 base 2 divided by log 4 base 2. Okay, so at the end of the day, we're going to replace 8 with 2 raised to the power 3. So you have 2, in place of 8 you put 2 raised to the power 3. In place of 4 you put 2 raised to the power 2. So what do? You take the 3 behind the log. You take the 2 behind the log as well. So this simplifies to 3 log 2 base 2 over 2 log 2 base 2. Log 2 base 2 is 1, log 2 base 2 is 1. So this is going to get out, this is going to get out. Or this can even cancel this at once. So the answer here is 3 over 2. So log 8 base 4 is 3 over 2. So you had half. The half times log 8 base 4. This is log 8 to base 4 is actually 3 over 2. So this is going to be 3 over 4. Okay. So we've gotten this part as 3 over 4. Now let's solve for this part. This is log 32 base 4. 32 is the same thing as 2 raised to power 5. 4 is 2 raised to power 2. So we can actually apply change of base concept. They have a common base, base 2, base 2. So you're going to use base 2 in changing the base. So this is going to be log 32 to base 2 over log 4 to base 2. So this is going to be log 2 raised to power 5 all over log 2 raised to power 2 base 2. So the 5 is going to come behind, the 2 is going to come behind. So you have 5 log 2 base 2 all over. The 2 comes behind here. You have 2 log 2 base 2. At the end of the day, log 2 base 2 is 1, log 2 base 2 is 1. So you are going to end up with 5 over 2. Okay. So it remains the log of 2 to base 4. So we've actually gotten this side as 3 over 4, gotten this part as 5 over 2. So it remains the last part, log 2 to base 4. So let's go ahead and solve that part. So you have this is 3 over 4 plus 5 over 2. Okay. This is for this part. Why this is for this part? It remains the last one. So let me rub off the board. So for the last part, we have log 2 base 4. So this is 2 raised to power 1, this is 2 raised to power 2. So we're going to use change of base concept. They have a common base 2, so it's going to be base 2. So this is equals to log 2 base 2 all over log 4 base 2. Okay? Now, log 2 base 2 is 1. Log 4 is the same as 2 raised to power 2, so you can write this as log 2 raised to power 2 base 2. You now bring the 2 behind the log, so this is going to be 1 over 2 log 2 base 2. Okay, so log 2 base 2 is what? 1. Is 1. So 1 times 2, you have 2. So at the end of the day, you have half. So this part is equals to half. Okay? That part is actually equals to half. So at the end of the day, you have the first part is going to be 3 over 4 plus 5 over 2 minus half. So let me use the concept of an equivalent fraction. This is the same thing as 3 over 4 plus 10 over 4. You multiply this by 2, multiply this by 2, multiply this by 2,
multiplied by 2. So at the end of the day, you have 3 plus 4 is 3. Sorry, 3 plus 10 is 13. 13 minus 2 is 11. 11 over 4. Final answer is 11 over 4, which is the same thing as 2 whole number 3 over 4 in mixed fraction as a mixed number. This is 2 whole number 3 over 4 or 11 over 4. That is our final answer here. We took it in bits. Okay, we actually took it in bits. Okay, but how about if we didn't want to take it in bits? We could have just taken it as ones as let me show you this second method we could have used. There are many methods one can actually use. Okay, so we could have just write this as log 4. Okay, let me not use that method because the sound is going to make things somehow complicated. It's going to make things complicated for us. So let me solve another example. Now, given that log 2 base 10 is 0.3010 and log 3 to base 10 is 0.4771 and log 5 base 10 is equals to 0.6990. Simplify. Find the value of log 6 base 10. Find the value of log 6 base 10. So, given log 2 to be this, given log 3 to be this, given log 5 to be this, find the value of log 6 base 10. So, how do we solve this? Without tables, without calculator. So, we are expected to show you working. So, we're going to make use of the concept. We will try to break this 6 down in terms of 2, 3, and 5. 6. Which combination can give you 6? 2 times 3 gives you 6. So you can actually write log 6 base 10 as equals to log 2 times 3 base 10. So at the end of the day, you can apply the first rule of logarithm, which states that when you have 2 logs being added together, you can actually multiply the numbers. So now we're going to reverse it. These numbers are being multiplied. We're going to add the logs together. So this is going to be log 2 base 10 plus log 3 base 10. So this is log 2 base 10 is 0.3010, while log 3 base 10 is 0.4771. So you add this together, this is 1877. So that means that log 6 base 10 is 0.7781. You can actually check to confirm with your calculator or from the tables, your log tables. Okay, so this is the final answer. So we're going to take another one. Log 10 log of half to base 10. we want to find the value of the log of half to base 10. The log of half to base 10. So this is 1 divided by 2. So we're going to apply the subtraction rule. When things are divided, you can actually apply subtraction. So this can log half base 10 can actually be written as log 1 base 10 minus log 2 base 10. So what is log of 1 to base 10? In our first or second class on logarithm, our first class, where I gave you the rules of logarithm, I said that the log of 1 to any base is what? Can you guess? Okay? I said that the log of 1 to any base is 0. So the log of 1 to base 10 is 0. Log of 2, this is 0.3010. So final answer is minus 0.3010. That is the log of half to base 10. That's the final answer there. Okay? So let's still do one more. Let's still do one more. Or two more, not one more. We're going to try lay hands on two more. So I've cleaned okay, I'll still write again. The log of 3 to base 10, that is 0.4771. The log of 5 to base 10, that is 0.6771. Let me confirm that. 699. 0. So if the log of 35 to base 10 minus the log of 17.5 to base 10, find the value of this. So this is quite easy. So this is subtraction. So you're going to divide 35 divided by 17.5. So you have, since the base are common, log 10, so this is going to be log 35 to divided by 17.5 to base 10. 35 divided by 17.5 is 2. So this is log, this divided by this gives you 2. So this is log 2 base 10, which is equal to 0.30110. Okay, so this is the solution here. So another one, quickly another one. If half log y plus 3 to base 2 is equals to 2x. Express y in terms of x. So here you are asked to express y in terms of x if this is equal to this. So we are going to write this as this is going to be log y plus 3 raised to power 2 base 2 equals to 2x. Okay, so this is the logarithmic form. Now we're going to rewrite this in the index form. So in the index form, this is going to be y plus 3 raised to power 2 equals to 2 raised to power 2x. Yes. Sorry, I made a mistake. This is supposed to be raised to power half, not. This is supposed to be raised to power half, not 2. This is half here. Sorry. Very sorry. This is half. Raised to power half here. Okay. So this is the same thing as square root of y plus 3 equals to 2 raised to power x. We can actually write this as this. Bring the x into the bracket and keep the 2 outside. These are still powers. 2 times x, 2x. It's still the same thing written in another way. So this can actually be written as this. So since they said we should find y, express y in terms of x, this is a square root. The only way we can clear the square root is to square this thing, as in multiply root y plus 3 times root y plus 3. So we're going to square both sides. Square both sides. That is multiply both sides by itself. Okay, so now we know that root 2 times root 2 is equals to 2. When you multiply a root by itself, the root disappears, the number just stays alone. So this, the root of y plus 3 times the root of y plus 3 will give you y plus 3. So here you have 2x into 2 times 2x into 2. So this is at the end of the day, I could have just, okay, let me just combine this as 2x originally as it is. It's easier that way. So based on the law of indices, you have a common base 2 base 2, so you're going to add 2x plus 2x. That will give you 4x. So this is 2 raised to power 4x equals to y plus 3. Okay, so y is equals to 2 raised to power 4x minus 3. Y is equals to 2 raised to power 4x minus 3. This can, or you can even still write this as 2x raised to power 4 minus 3. So any of this is correct. This is the final answer. So we're going to stop here at this point. So I hope you've enjoyed the class. So please just take your time and take your pencil, take your pen, take your paper and try to solve along. If you have any issue, you can communicate with me via the social media platforms or through the comment section. So thank you. At this point, I'm going to call it a day. So please subscribe to this channel like the video, click on the bell icon so you always be notified whenever we upload any video. Thank you so much. Bye.
So thank you so much for being a part of this lesson. We hope you actually enjoy. In case you have any question or you have any comments, you have any contribution, feel free to drop them in the comment section, or you can also connect with me via my social media platforms. So on WhatsApp, this is my WhatsApp number, and on Instagram, this is my Instagram account username, Edison number 4 real. This is my WhatsApp number. So feel free to connect with me via my social media platforms, and please subscribe. Make sure you subscribe. Click on the bell icon so you always be notified whenever I upload a new video. And also, please go ahead and like the video. So with this lesson, actually, for now, we've come to an end on our series on logarithm. We might still go further and solve more exercises along the line. But for now, we've come to an end. So we're going to move to a new topic, a new lesson in our next class. So watch out for our next lesson and stay tuned, please. Bye. God bless you.